Alright, welcome, and today we'll be talking about ellipses. Boy, do I have a lot of information for you. Okay, now ellipses, these type of ellipses, we're going to have them just centered at the origin. So your center is just going to be 0, 0. Okay, but, and that checks off that. Boop. Okay. Alright, now we're also going to talk about co-vertices, focus of an ellipse, major axis, minor axis, and vertices of an ellipse. Okay, so first off, we're going to talk about an ellipse. Now, an ellipse is a shape that if you picked any point on the ellipse and then found the distance between it and one of the foci and then added that with the same point to the distance of the second foci, you would get a constant number. Okay, so in other words, if I pick a, let's say that for some reason the focus was right here and the other focus was right here, and they're always going, it's going to be nice and symmetrical. Okay, so if I pick a line, okay, so if I pick a point right here, all right, and then I draw a line from here to here and then from here to the second focus, okay, that would be the same exact, if I added up those two distances, that would be the same as if I picked a point here and then added up these two. Okay, now granted these segments are not going to be congruent, but anytime I pick a point on the ellipse, okay, and then find the distance between it and the two foci, those distances will always be the same. Those additions, the sum. Okay, it's just amazing how it works. It's a really cool thing. Now this is actually answers an age-old question, especially in astronomy, which was they couldn't predict the motion of planets. They had to do several circles. They had to do circles like what we just learned. And finally, a man named Tycho Brahe decided to come up with an ellipse. An ellipse has two foci in the middle. A circle has one center. And an ellipse, it's almost like you took the center and you stretched it out from each other. It's like you split it off like I think it's mitosis or meiosis, wherever the cell division splits apart, where you take the nucleus and you split it apart. This is what that's doing. Okay? And so they split it apart. And once he applied that model of foci and ellipses to the actual planetary motions, it explained it perfectly. And that's one of the beautiful things about this. And that man, if you want to go look him up, Tycho Brahe, I think he was either Austrian or Norwegian, but he was crazy. He had a pet tiger. That's how awesome this guy was. Okay, so that's how a focus works, and that's what an ellipse is. It's basically a circle is a figure whose all the outermost points are equal distant from the center. A foci is this formula right here. Okay, it's where you take any point and then find the distance to both focuses and then add them up, and you will always get a constant number. Okay? Alright, so it's pretty simple like that. Now, there's two versions of the ellipses, and then also I want to point out to you guys that there's a huge formula over here to help explain a certain letter, and that letter is C. Now, if you look in your formulas, x squared divided by a squared plus y squared divided by b squared equals 1, and then there's one where the a switches to underneath the y and the b switches to underneath the x. And that's important because a is going to be the bigger number than b. Okay? Alright, so it just depends on which one you're using. So, if you find that a is underneath x, you are dealing with a horizontal ellipse. So this is a horizontal ellipse. Okay, so this is a horizontal ellipse, and that means that this is a vertical ellipse. Okay, and what that means is that a is underneath the y, so it's going to be the bigger one. It's going to be stretching out this way, which makes sense. Okay. All right. So focus of an ellipse is just these 2 points. Now they're a little bit harder to find, but you can actually use some formulas to actually work with it. Okay. Alright, so major axis, real fast. Major axis. Okay, major axis is obviously going to be the longer of the two. Okay, so that's the major axis. Alright, and minor axis is going to be the shorter of the two. It's the distance across. I like to call the width. Okay, so the major axis and the minor axis are here marked in red and blue. Okay, and you can actually find their lengths by looking at these spots. Okay, right here and right here. Okay, and they're actually pretty simple formulas. Okay, so now let me see, vertices. Vertices are going to be these points up here. So that's a vertex, that's a vertex. So I will call those capital V's for vertices. So vertice, and same thing here, vertice, vertice. Okay, and then co-vertices are going to be the other points. So co-vertice, 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 and co-vertice. Okay, now in order to find the focus, you need C. And how do we get C? We set up this equation. C squared is A squared minus B squared. So we need to subtract the A squared and the B squared, which are given to us. And then we square root it, and we get what C is. And so we put C, and that's our foci. Okay, and for horizontal ellipse, there's going to be two foci, one at positive C, comma 0, and one at negative C, comma 0. And then, as you can see, for the vertical foci, the focus is flipped, so it's almost it's a reversed order. So it's going to be 0, comma C and 0, comma negative C. Okay, so it's all set up like that. Now vertices are pretty easy. All you do is square root whatever A squared is, and you get the vertices. The x-intercepts, well, this one should be technically y-intercept. Let me change that. I accidentally typed in that one. Okay, there we go. Okay, so the x and y-intercepts are also known as the co-vertices. Okay, but the y-intercepts, you just square root the b and then use this formula for the horizontal and then use this formula for the vertical. Alright, and the length of the major axis is 2 times a, the length of the minor axis in both is 2 times b, so that's the same in both. Okay, once again, you don't need to know about the actual center, because the center is always going to be 0, 0. But this is one of the more important parts that you're going to need to remember, is c squared equals a squared minus b squared. Now, just so you know, in hyperbolas, when we get there, it's going to be the reverse. You're going to be doing a squared plus b, or it's going to be a squared plus b squared. Okay? Alright, and that is it for this part. We're going to actually go and practice some problems. Okay, so when I'm working on stuff like this, when I'm working with anything with a conic, I have my conic section formulas right with me. I don't mess around. Do not mince words with this, okay? Okay, so vertex is at 0, 6 and a covertex at negative 5, 0. Okay, we're going to get the equation of that. And also, we're going to give the focus. Okay, so what is the equation of the ellipse with a vertex at 0, 6 and a covertex at negative 5, 0? Okay, so what we're going to do is notice that the only one on your sheet that is, or in your formula set, that's going to have a 0, 6 is going to be a vertical. Okay, so if we take a look at it, the only one that has that all set up is vertical right there. So we're all set. So, in other words, we're going to be filling out this equation. X squared divided by b squared plus y squared divided by a squared equals 1. And you can reverse them, you know, the law of commutativity. I'm totally fine with it. Okay, so first off, we have to recognize that C is 6. Okay. Well, actually, no, that's not C. That's a vertex. That is A. So A is 6. Okay, and we're going to also recognize that B is 5. Okay. All right. So C squared is going to be 36 minus 25, and just realize you're never going to get a negative number here. Okay. So C squared equals 11. Okay. So C equals the square root of 11. Okay. Now this is going to be a plus or minus version. Okay, because there's going to be 2 of them. So when you do this, you should be all set. Okay. All right, now that we also know a, we can just plug it in here. So this is going to be x squared divided by 25 plus y squared divided by 36 equals 1. So that's my equation. That's pretty simple. All right, but then my foci, and yes, this is Latin for the focus. Okay, so the focus is going to be 0 comma c. So it's going to be 0 comma nope, positive root 11, and then also 0 comma negative root 11. Okay, and that's how we do that one. Now to find the foci of this equation, okay, this one's going to be a lot of fun. This one's pretty simple in beginning, because once you do the first step it really becomes clear how to do this, is you're going to divide everything by 225. Alright, now when we divide by 225, let me see, you need to reduce each fraction. Okay, so this is going to be x squared over 9, and then this one's going to turn into y squared over 25 equals 1. And now I have everything set up to where I can work it. Now this one's going to be a, and this one's going to be b, okay? And we're dealing with a, we already have this all set up, so we just need to find the foci, okay? So that's going to be c squared, so c squared equals 25 minus 9, okay, which is going to turn into 16, and we all know that c is going to turn into plus or minus 4. Okay. All right, now which foci formula do I use? Well, if you recognize, if you take a look at this, the y has the biggest, it has the a underneath it, so that's going to be another vertical ellipse. If you graph it, you'll be able to see that really easily. Okay, graphing is another way just to check to see what kind of ellipse you're working with. Okay, so the foci, and you can just write it like this, is going to be 0 comma plus or minus 4. And voila, I have my foci. I'm all set. Okay, so it's pretty simple stuff like that. All right. Oh, and just so you know, the major axis, just to cover some more bases, major axis is going to be 2 times a, and a is going to be 5. So it's going to be 2 times 5, which should be 10. And the minor axis is going to be 2 times 3, which is going to be 6. Okay. Do not go 2 times 25 for the major axis, because that's not the actual length. Okay. All right. What is the equation of the ellipse whose major and minor axes are 18 and 4? Okay. So the major axis is 18, so 18 equals 2a is how we set that up. And the other one is 14 equals 2a. Okay, so we know that a is going to be 9, and b is going to be 7. Okay, all right, now if you notice, I did not specify which one you could use. So let's say that this is horizontal, just so you can see a difference. Okay, what is the equation of the horizontal ellipse whose major and minor axes are like this? Okay, so we're going to have x squared over 81 plus y squared over 49 equals 1. Okay, and voila, I have my equation. Okay, now we're going to take a look at the graph. Okay, so once again, we're on interactive mathematics, and here's the actual setup of it. Okay, so in other words, okay, if I were to take the distance here to this point here, and then add that up with the distance from here to this point here, I would get the same number. Okay, and that would also work over here, there, I mean, however many times you go around it. Okay, all right, and this is actually the motion of an object in a elliptical path. Okay, so this is the object, and it has 2 foci, or 2 like center-like objects. Okay, and that is it for working with ellipses. I'll talk to you later. Bye.